Hi, I'm Alex from FAC Technology, and we're a composite materials company here in London. Currently, we're looking at switching over our production capabilities from composite materials to things like hand gel and protective clothing for people in the NHS and other people who are providing care to our communities at this challenging time. Thought this would be a great time to post my first video like this, because I've just got experiments running in the background. I've got a bit of breathing space right now. And I thought this would be a good time to talk about a class of experiments that we're doing, which fall under the class of chromatography. Now, if you go online and search chromatography experiment, you'll see loads of great examples of experiments you can do at home with your kids or for yourself to learn about the principles that scientists and engineers like myself are using to try and help solve some of the problems our NHS is facing. So if you look at those videos, you'll see that they typically use coffee paper or filter paper to basically separate out different chemicals from a liquid. And that's exactly what we're trying to do here. So what we're interested in doing is seeing if our equipment, when we switch it over from making materials which have hazardous precursor chemicals, can we safely switch that equipment to making hand sanitizer and ensure there are no contaminants in there which are actually going to harm the people who need it most right now. So I'm going to take this back and show a picture of the setup that we're using. So this machine here is called a Acurity APC PQMS. Not the most catchy name, but this is a great piece of kit. In fact, this is the first one ever to be delivered in Europe. It's their Water's latest greatest gel permeation chromatography or size exclusion chromatography setup. Now, in the experiments that you'll see online, what people do is use filter paper to separate out different chemicals. And that's what we're doing. We're separating out chemicals in the liquid to see what's there, or hopefully by the end of our filtering and flushing process of our production equipment, to prove that nothing is still there, or certainly not there in any quantity that would be harmful. So rather than using filter paper, we use these things, which we just call columns, but inside them are packed very specially designed in terms of chemistry, size distribution, packing, beads. And those beads will slow down the rate at which chemicals will go through them. And they slow the rate of different chemicals down in different ways. So what we're doing is selecting columns which we think are the most suitable material that's for what we're looking for, or what we hope to not find once we're done with our flushing process. And what we do is we then put them into our machines in temperature controlled boxes like this. And we have samples. I'm not going to open it now, but we have temperature controlled compartments which contain little samples. So that's what a sample looks like. And essentially what happens is sample material from there gets mixed with a carrier liquid or solvent, and then the whole liquid flows through the columns, and different components in there, different contaminants, will all get separated out over time. We then have different detectors, or these are bits of equipment which can detect different attributes of the chemicals going through them, like how they refract light, how they deflect light, and things like that. So using that whole range of tools, we can find out what is actually coming out of any production line that we produce. So hopefully once we're set up and ready to go with making hand sanitizer, we've suitably checked everything beforehand, determined there were no unsafe contaminants. We can then run the material. We'll also then do some subsequent testing using chromatography and other methods to ensure once again that there are no harmful contaminants in there. And then hopefully we can then start cranking out a couple of tons a day to help the people that need it most. But probably more importantly is show to other companies who have equipment like us, and there are a lot of companies in the aerospace and probably automotive supply chains who have equipment like ours that could be switched. And if we can do that, then we can probably solve our country's needs pretty much overnight. And hopefully lots of people in other countries would do the same for their communities there. So with that, I'm going to sign off and get back to work.